Okay. So again, yesterday we looked at, first of all, what a polynomial was and how to factor it. All right. And for the homework, right, we use GCF to factor. Greatest common factor to factor out some polynomials, okay? So greatest common factor is like one tool that you're going to have in your toolbox when it comes to factoring, okay? Here the directions explicitly said factor the common factor out of each expression, but when you work later on into Algebra 2 and pre-calculus, you could be asked to factor, to solve, just like you could just be asked like just plainly to factor the polynomial, okay, which does not really give you any guidelines about what to use, okay. You'll need to become savvy with the different tools that you have. So one tool that we developed yesterday, greatest common factor, looking for things that are in common between all your terms and then dividing those out, okay. Greatest common factor is a nice tool because it works for pretty much any polynomial. Well, I mean, you can use it on pretty much any polynomial, right? We had binomials where we took out a greatest common factor. We had trinomials, 1, 2, 3, right? We had 4-term polynomials we factored it out of, and I think that's as big as we got yesterday. Yeah. Okay. Today we're going to look at factoring trinomials. It's going to work on a more limited set of problems, but it's highlighted because we spend a lot of time looking at these. Like, right, Algebra 1 last year, you guys like talked a lot about like parabolas and graphing the parabolas and like figuring out where the vertex was and where the zeros are and all that good stuff. And that's what it kind of lends itself into this too. That's where we spend some time there. Okay, so you're going to look more at that kind of thing, I think, again in Algebra 2 as well. So we're going to start off, okay, by factoring trinomials of the form x squared plus bx plus c. Actually, I'm going to put an a. Ax squared plus bx plus c, but we're going to look specifically when a is equal to 1. So that's when the lead coefficient here in front of the x squared is a positive 1. All right. Later in class, we'll look at factoring when a is not 1, when it's like a 2 or a 3 or a 4, something like that. Okay, it makes things a little bit trickier. We're going to start with a more basic example right here of 1. Okay. And the idea is that we want to take this like generic x squared plus bx plus c. All right, and our goal is to see if we can break it up into 2 binomials. Okay, they would both have an x in front because we needed the x times x to make the x squared there. But then it's a matter of what are these 2 numbers going to be right in here? We don't know. We got to figure out what those numbers would have to be to then get us back to multiply to get us to this quadratic this trinomial. Okay, and so there's a lot of different strategies people use to do this, all right, and you'll learn a lot of different strategies, but the strategy we're going to focus on here today involves using something called the product sum kind of method. Okay, so our goal here is to factor the trinomial. That's going to be our direction. So we're going to go right into, we're going to go right into a problem here. So, for example, okay, let's say we've got x squared plus 6x plus 8. I'm going to factor that. Okay. Now we saw back in the warm-up, right, that again we're trying to make this factor so we have x plus something and x plus another something. We want to fill in those kind of blanks there. So yeah, Evan?
4 and 2.
4 and 2, okay. And so how do you know it's going to be 4 and 2?
Well, if 8, you just put the line 4 and that gives you 2. And if you add 4 and 2 x together, then that's
Right, so we want to consider, okay, basically what we're looking here is we want to, first, we want to go to the number at the end here. So I'm going to, like a number 1, step 1 here. You want to think of two numbers, okay, that multiply to 8. All right, so did Evan have to choose 2 and 4? You could have, what else could you have chosen there, Evan?
I could have chosen... No, I don't think... Is there?
There's one other pair that's like the obvious, it's like the easy pair that people forget about because it's so easy. It's like, well, duh, yes, of course, they multiply to make 8. Anyone help them out? What is it?
8 and 1.
Yeah, 1 and 8. 8 and 1. Yeah, 1 and 8, 8 and 1. Right. Yeah, okay. So that's like the obvious, but no one ever thinks about that one because it's like, oh, of course 8 times 1 is 8. But you don't, that's, you know, whatever. So, but we want to consider those. So we look for two numbers that multiply to 8, and then step 2, we want to then make sure that those same two numbers that add to make to 6. Okay. So two numbers that multiply to make 8 but add to make 6. And so Evan's exactly right there, and some of you guys are good with your mental math and you're able to see it right away, 2 and 4. All right? That's what makes that work there. Okay. Now what if I had put x plus 4 and x plus 2? Is that okay? Yeah, right? Okay. It's just changing the order of the multiplication around. But 2 times 3 is the same thing as 3 times 2, so x plus 2 times x plus 4 will be the same thing as x plus 4 times x plus 2. We can flip that order around. No problemo. Okay. But by the way, though, are 2, 4, and 1 and 8, are those the only two numbers? Well, I guess I should say 2 and 4, 1 and 8, but we don't want to forget we could also have done here like -2 and -4, -1 and -8 as well, right? -2 times -4 makes positive 8. -1 times -8 also makes positive 8 there, but they wouldn't add, of course, to the correct thing. This is our correct pairing right there that we want. Okay. How can we check to see that this is correct? What do we do? Yeah, and multiply this back out. Okay. But since the directions are told us to factor here, we're actually done though. We don't. I mean, you can check it, right? But this is where we stop. Okay. I know sometimes it's like just 2 days ago we were taking this, multiplying it to get to this, and now we're going backwards. So I know it can get a little confusing, but this is what we're asked to factor. We broke it into 2 factors there. Okay. So we divided this up into 2 factors. So that's how we know we're done there. We got our 2 factors. Okay. All right. Let's try another one. Let's try y squared plus 91y plus 90. Okay, y squared plus 91y plus 90. So again, we want to think of two numbers that multiply to make 90, but then add to make 91. Okay, so two numbers that multiply to make 90. So let's go to... Oh, why are you called on Evan? Sorry, Evan, I want to pick someone else. Give him a shot. Shannon, give me two numbers that multiply to make 90. 9 and 10. Very good. They do. Our 9 and 10, though, are two that we want. How do you know, Shannon? Yeah, they're not going to add up to make that 91 that we're going to need there, right? We know that, oops, sorry, I started using an X there. We know that we need these two y's, right, to multiply to make y squared, but 9 and 10 aren't going to be the two numbers there because they won't add up to make that middle term that we need. All right, Shannon, you got another pair? That pair of numbers that multiply to make 90? Sure, 18 and 5. Is that it, though? Nope, 18 and 5 also do not work. Interesting. All right, let's see here. Adam, how about you? Do you have any for us? Any pairs?
Yeah.
All right, what you got? 90 and 1. Ah, okay. And is that the right pair? Yeah, they add up to 91, don't they? So 90 and 1. Okay. So that's exactly right. There it is. Of course, don't forget we could have done -9, -10, -18, -5, -90, -1, all that good stuff too. So that's right. Okay. All right, questions on any of that? All right, cool. Then we'll give you 2 to try here. All right, so try n squared plus 13n plus 36. And then try c squared plus 7c plus 7. Okay. Go ahead and give those a shot. All right, let's see what we got here. Let's go to Melissa. N squared plus 13n plus 36. Did you get the factor there to something?
Yeah, I got n plus 4 and n plus 9.
Aha, n plus 4, n plus 9. Very good. Okay, yep, looks good to me. Equals that n plus 4 times n plus 9. So these two things right here, they are equivalent. Okay, they're saying the exact same thing. All right, next one there, c squared plus 7c plus 7. Let's go to Mary. What'd you get there, Mary?
No solution.
No solution. Yeah, it doesn't factor. It doesn't factor, okay? So my point there, okay, Mr. Remar did not make a mistake, believe it or not. I intended, okay, to write this one. And the point is because these things won't always factor, okay? These things won't always factor. Right? So in this case, it doesn't factor. Not possible. Okay, does not factor. In fact, let me see if there's actually any sort of solutions to this. One second here, hold on. Okay. It's just so close it looked like it was. So, all right. So yeah, there's no factors there for that. Doesn't factor. Not nicely like we have the past ones there. All right. Okay, so there's those. But that's not the only kind of thing we could run across, right? So for example here, one other thing there's one thing else I wanted to point out here. Oh yes. Why do you think that we go for the number that we're going to multiply? So again, we're trying to find two numbers. Why do we go for the number we're going to multiply to get? Why don't we start looking for numbers that we add to get this, and then check to see that they multiply to give us this? Why do you think that is, Evan?
Because
You can think about it. Maria, what do you think?
Because, like, there's, like, a ton of ways that you can
numbers to add up to that number, but not multiply. It's easier to find multiplication first than the addition.
That's right, because we're lazy, and we want to do as little work as possible. So if we start trying to look at the numbers that multiply to make 90, we'll have a much shorter list, like Maria said, than we will for the numbers that add up to make 91. And that's the whole purpose. Yes, exactly right. Could you do it in reverse order? Absolutely, absolutely. Maria's probably going to do that later because she likes math so much. She's going to start with the addition one and then start trying to see what it multiplies. But everyone else, you don't have to, okay? All right. Here we go. We're going to try this next one here. So again, same directions, but now let's change things up a little bit. Okay. How about so now we're going to change some signs. SIGN signs. Not trigonometry signs. Not SINE. SIGN signs. Okay. Maria says she knows this one. So what is it then? -5, -2. Okay, yeah, that's exactly right. So E minus 5, E minus 2. All right. So what'd you do, Maria? How'd you get that so quick?
Because, I don't know, I just knew it.
You just knew it. Okay, so what were you checking?
It was like, it had to be negative to add up to like 7.
Okay, so when you say it had to be negative, what had to be negative?
The 7, like the numbers, because you can't have one negative and a positive, because then the 10 would have ended up negative. So you have to have 2 negatives, and then you do -5 and negative.
So that's very good. Okay, that's right. Very good to point that out here. So in this situation, our third number here, right? This is a positive number. So you might think, oh, both our numbers we're looking for are going to be positive, but then since our middle term's negative, well, the only way you can end up with a negative sum but a positive product is if they're both negative. And so that gives us a clue that the sign of them will both be negative. Okay? And so but it's still the same kind of principle. You got to figure out two numbers that multiply and make 10. Now it's helpful, like Maria was saying here, to see that, okay, well, we know they have to both be negative, so we just think of two numbers that multiply and make positive 10. So we could say, okay, -10, -1, but they wouldn't add up to -7, but -2 and -5, the only other option they do. They would add up to -7 and they multiply and make positive 10. So there it is. Okay, good, that's right. All right, how about x squared plus 3x minus 54. Okay, x squared plus 3x minus 54. So now, since we know we're multiplying to be -54, that means what's going to be true about our two numbers? Anyone want to say? What about the signs for our two numbers? Yeah, Drew?
One's positive and one's negative.
Yeah, one's going to be positive, one's going to be negative, okay? And then since that middle term is a positive 3, the smaller number has to be negative. So, Michael, you have the answer for us? X plus 9 and x minus 6. Okay. You like that? Does that look good? Yeah? 6 times -9. Sorry, 9 times -6, -54, and then the 9 and the -6 will add together, give us that 3x there when you distribute and stuff. So, yeah, that's right. All right. So there are those questions there. Let's see if I got some for you here to try on your own. No. Okay. Yes, back here. Okay. Oh, fun. Okay. Well, what about a problem like this? 5b squared minus 30b plus 40. What should we do here? Yeah, Ken?
You divide something by 5.
Right, so if we look at this right away, we might be like, oh man, we haven't talked about what happens when we have a coefficient of 5 in front of the b squared term. We will talk about that in a little bit here. Right now, with the way it's written, we would be kind of stuck, though. We haven't really seen that. Maybe you guys do know how to do that, or maybe remember from last year, but we haven't looked at that yet. We haven't reviewed that yet. We just have seen with 1. So, but yes, Tanner, very good. When you're just told to factor like this, don't forget you have that tool at your disposal of factoring out a GCF, and that's what we're going to do here. We're going to factor out a 5, and so if we do that, Tanner, what are we left with?
You're up to b squared.
Okay, b squared
Minus 6b.
minus 6b plus 8. And now if you look inside parentheses, we do have a trinomial with a coefficient of 1, right? There's like a 1 right there, right? Okay. Ugh. So, let's see. Go to someone we haven't talked to yet. So like Lindsay then, what, can you give me 2 numbers that multiply to make positive 8 there, but they're going to have to add to make negative 6. So you keep going.
-4, -2.
Negative 4, negative 2. Great. So that becomes then, we'll still have the 5 there. The 5's still there, right? But it can become b minus 4, b minus 2. Okay? And so there that is factored. 5 times b minus 4 times b minus 2. Okay? So yeah, keep on your toes there. Don't lose that. Okay? It's possible to factor it still. Let's see there. Okay, cool. So there's that. I'm not going to have you guys do any like on your own with that because I think you're all pretty good there. Any questions on that? We're all okay on that? We're all good. Okay. So now let's look at what happens then when we have a not equal to 1. Okay. So factoring trinomials a not equal to 1. Okay. That gets a little bit more complicated. A little bit. Or a lot of it. Sometimes. Okay. So. Alright. Let me see if I can pick a nice one out here. Alright, we'll go with this one. So let's do something like, oof. Sorry, I'm just thinking here. Okay, I got one. Alright. 5n squared minus 9n minus 2. Okay. So this is a little bit trickier. We cannot just go and say we need to think of 2 numbers that multiply to make negative 2 and add to make negative 9. Well, because right now, if we try to think about that, we don't know. There aren't 2 numbers that multiply to make negative 2 but add to make negative 9, right? That's impossible. This thing does actually factor, though. So let's start back off by drawing our little parentheses there, right? It's got to be 2 binomials. Okay, we know that we need an n here and an n here, but actually we know more than that, don't we? What about the coefficients of these n's? We can't just do n times n. That'll give us n squared, but what do we need? We need 5n squared, so one of these has to have a what in front of it? It's got to have a 5, right? It doesn't matter which one you pick. In this case, right, you can put the 5n here, you can put the 5n here. It doesn't matter. Okay? So 5n to 5n. Okay. And then these 2 numbers over here, what do these 2 numbers have to multiply to be? Yeah, these 2 numbers here still have to multiply to make negative 2. All right, so that means I could write 5n minus 1 n plus 2. I could write 5n plus 1 n minus 2, I could write 5n minus 2 n plus 1, or I could write 5n plus, 5n plus 2 n minus 1. Oof. So which one is it? Which one gives us the right one?
First one.
The first one does? How do you know?
Because n is negative 9n.
So let's see here. The 5n is going to multiply to the n to give us 5n squared. 5n times 2 is going to give us 10n, positive 10n. Minus 1n times minus n, minus 1 times n is minus 1n. So 10n minus 1n is going to give us positive 9n. So it's actually not that one. So it's the second one. Well, let's check the second one. 5n times a negative 2, negative 10n, plus 1n, negative 9n. 1 times negative 2, negative 2. So yeah, it's actually the second one here. Okay? You can see how difficult this gets. Now, do I expect you guys to write out all 4 options here? No, okay? But back when I was learning this stuff, kind of like you guys did, and maybe are now somewhat, if it's like a refresher to you or something like that, it involves some guessing and checking. Okay, you kind of have to just play around with it some. Now that sounds painful, and it is, or it was, but the more familiarity you gain with this, it helps you with your like mental calculations, because it will help you like calculate things in your brain a little bit better, and it'll also help you, kind of just become more adept with this stuff because you'll get the practice. Okay, there are alternative methods, and I'll show you those maybe tomorrow for like shortcuts and stuff like that. But for now, I'm going to have you guys kind of struggle through this a little bit. Okay, that's the way it's going to be, because I think it's helpful. But there are shortcuts, but they have, kind of like less meaning. They're just kind of like tricks. All right, let's try another one here. Let's see. All right, I want to do one. All right. Pick one here. So let's go with... all right, I'll just do it. Whatever. Here we go. 4n squared minus 15n minus 25. Okay. All right. So again, we know it's got to break, well, hopefully we're going to try and break it down into 2 binomials. We know we have to have an n here, we've got to have an n here as well. But what about the coefficients of these n's? What are they going to be? Evan? 3n and 1n? That wouldn't multiply. That we needed to multiply. Remember, it's going to multiply to make 4n squared. So it has to be what? 4 and 1. Okay, or 4. Does it have to be 4 though? What else could we choose? Yeah, we could also do 2 and 2. You can see now how this gets a little more complicated. So it's like, all right, here this one was obvious. To get 5, it's got to be 5 and 1. So 1 has to be 5, 1 has to be 1. But here we could have 4 and 1. We could have 1 and 4. We could have 2 and 2. And so again, this is a matter of kind of like guessing and checking almost. So let's try 4 and 1 since that's what we heard first. Okay, let's try 4 and 1 there. All right, so if we're going to use the 4 and the 1, so then over here we have to now multiply to make negative 25. Well, that's nice because negative 25 doesn't have too many things that it could be there, right? We can multiply. So how can we multiply to make negative 25? What can we do?
Negative 5 and 5.
Okay, so you want to put the negative 5 here and the positive 5 here?
Sure.
What you're saying? Okay. So now let's just check our work. Let's see if we're right. So negative 5 times n is negative 5n. 4n times 5 is 20n. So 20n minus 5n is positive 15n. Ooh, that's really close because what do we want? Negative 15. So how can we fix this then to make it work right? We had a negative 5n and then the 20n that made positive 15. We want this to be negative. So what can we do? Instead of making this negative 5 and positive 5, what can we do instead? Yeah, flip them. So not that order. We'll try 4n plus 5 and then n minus 5. Did that work? Let's see. 4n times n, 4n squared. 5 times n is 5n. Negative 5 times 4n is negative 20. So negative 20 plus 5, negative 15. 5 times negative 5, negative 25. That's our answer. That's the factored version there. Okay. Mr. Whitmire, what happens if I chose 2n and 2n? Then you would have tried to use 2n and 2n, and you would have seen that it wouldn't work. And then you'd have to switch to be like 4n and n. Okay? So that's the part of the insidious nature of some of these problems. You have a little bit of guessing and checking to do.
Is the number always going to be in the first parentheses, or will you sometimes have to split them up between the two?
Right. So split up between the two, you mean like, what do you mean by splitting up?
Like, so how it's 4n right now,
Mhm.
if you said it wouldn't work 2n and 2n.
Right.
Is that...
Sometimes 2n will be the one. Like sometimes you will, yes, exactly, yes. Sometimes you will have to split it up. Yes. Yes. Okay? And you can imagine if I give you a number like 12 out front here, well then it's like, well, is it 1 and 12? Or is it 2 and 6? Or is it 3 and 4? Or is it 4 and 3? Or is it 6 and 2? Or is it, 12 and 1? So, those, yes, it gets a little complicated. Now, obviously, I'm not going to give you 50 of those because it's a lot. You're right. It's a lot. Let's have you guys try one here. Okay, let's have you try one here. All right, let's do this one. 6x squared plus, I'll give you a nice one. Okay, this one's nice because we don't have to worry about what? All the signs are positive, so there's no negatives. They'll be all positive. So it's just a matter of figuring out what the correct combination of numbers will be. They give us a 37 in the middle there. Okay. So actually, I should probably do this one too because I have no idea what the answer is. Ooh, but I could cheat. I won't cheat. Okay. Oh yeah, these kind of problems back when I was doing this, there's a lot of erasing my paper. Sometimes I would make so many mistakes. I would erase my paper.
Back in my day, there, Evan.
They could be. You could try that and see what you think. Right. Yeah. I mean, if you All right, is anyone banging their head against the table yet? You are? Stick with it. If you're running with this, you can use more of your arm instead of your finger and stuff. Not like that. Now on this grip though, that might be as fun, but running away from you, Elizabeth. You got it? Okay.
I use my teeth because they can't go home.
That's nice. Nice. You're like a barbarian. All right. See, Sean, did you come up with something here?
Not yet.
Not yet? Okay. Kind of stuck. Mason, you come up with something?
Yeah.
What'd you get?
I got 6x plus 1 and x plus 6.
Uh-huh.
How do you do this?
So sometimes you guess right, you know what I mean? I mean, sometimes it's just a matter of like guessing correctly. Now, where did you go, Stephanie? Did you go for the 2x and 3x?
I did plus, plus.
Okay, okay, did you do 6x and x though? Okay. So I mean, so you're on the right path there. It's just a matter of flipping it around then. So yeah, you're right. I mean, but again, it comes with familiarity too. Like the more you do it, the easier it becomes because you'll kind of like, oh yeah, I got to flip these around to get the numbers high. I mean, one thing that I kind of looked at here, I was like, okay, 37. That's kind of a big number. So I probably need to like make sure that I'm multiplying. I know it's like close to 36, for example, and I have 6's in here, and 6 times 6 is 36, so like maybe I can get it to be like that. That's what I'm looking at. So I want this to be kind of a bigger number, so I want to multiply bigger numbers together, 6 and 6 together, not the 1 and the 6 kind of thing, if that makes sense. So that kind of helps me judge as well. Or if this number is smaller, then I try and make a bigger times a smaller, or a smaller times a smaller kind of thing. That can help you too, help you to figure that out. Any other questions on this? There is only one answer, right? Like you can't get this with 2x and 3x. So if you chose, to try and do 6x squared as 2x here, 3x here, it won't work, period. There's only one way to get this one, okay? Only one to break it down, and that's going to be true in general. If it factors, there will be one way to factor it. There won't be a couple different ways to do it. So, okay. Does anyone want to see the trick method to doing it? Yes? All right, so there's like a trick you can use here. And I'll show you with this one, just as a little side thing here, okay? Nope, I'm going to hold off till tomorrow. Nope, sorry. My conscience just kicked in.